Okay, you'll notice with these trig problems that one thing has changed, and that there's now a number with your variable. Remember, theta is the variable for trigonometry, and it stands for an angle. Very important to understand that when we solve a trig equation, we are looking for angles. So theta represents an angle. Okay? Only angles equal other angles. Numbers equal numbers. Things of that nature. So we solve this very similarly to how we've solved everything else we've done with trig. Meaning we do the easy things first. So, plus 1. Pretty easy. So 4 times the cosine of 2 theta, 2 times some angle, has got to equal 2, because 1 plus 1 is 2. Our next simple step is divide both sides by 4, because we're trying to get everything away from your trig word. So here we have the cosine of 2 times some angle equals 1/2. Okay? So remember, our job, our whole entire point of doing this is to get theta by itself. So what is the next thing prohibiting us from solving for theta? Well, it's the cosine, right? We work from the outside in. So the next thing to do is move. How do we move our cosine from one side to the other side? Okay? We do the inverse. We always are doing inverse operations. So we write inverse cosine of both sides. Okay? That is the formal way of getting rid of cosine, is by doing its inverse. So now we have our theta just hanging out, which is exactly what we want. It's no longer in parentheses. It's no longer being the cosine or multiplying by 4 or subtracting 1. It is free. But remember, theta is an angle. So we need to set it equal to an angle, which is why we've been doing this. What is the angle where the cosine is 1/2? The first one is at pi over 3. That's the first angle on our unit circle where the cosine is pi over 2. But where else on our unit circle is the cosine pi over 2? 5 pi over 3, right? There are 2 angles usually, right? Unless it's positive and negative, there are only going to be 2 angles for each of your trig values. So the cosine is 1/2 at pi over 3, and the cosine is 1/2 at 5 pi over 3. Okay, there are multiple angles on our unit circle with the same value, and we have to account for all of them. So now I have 2 times some angle equals pi over 3. An angle and an angle, our answer is going to be an angle. So we solve this by dividing by 2. Now, writing this divided by 2, right, that doesn't look so good. Pi over 3 divided by 2. So we're going to not divide by 2, but instead multiply by 1/2. Okay, so rather than dividing our fraction by 2, multiply your fraction by 1/2, and we get a much more, enjoyable answer, experience with multiplication. So pi over 3 times 1 over 2 is pi over 6. 5 pi over 3 times 1 over 2 is
5 pi over 6.
5 pi over 6. Okay, now here is the special part. If we look at where these angles are, pi over 6 is in the first quadrant. Okay, 30 degrees. 5 pi over 6 is in the second quadrant. Okay, we still have a whole entire half of our unit circle, that we could potentially get correct answers from. And that's the tricky part about these multiple angle problems, is we have multiple angles from your answers. So one way to do this, okay, is to simply add pi to each of your answers. So our first answer of pi over 6, if we add pi to pi over 6, what is our other answer? So here's our deal, right? What's our denominator of this fraction? In order to add a fraction to a non-fraction, I have to change this into a fraction. So how many sixths are there in 1 pi? 6. So I'm going to add 6 pi over 6. So what's 1 pi over 6 plus 6 pi over 6? 7 pi over 6, right? That's that angle over here. 7 pi over 6. And what about our 5 pi over 6? If I add 180 to 5 pi over 6, right, I'm going to add another 6 pi over 6. The denominators, anytime we have a denominator of 6, we're adding 6 over 6. If I had a denominator of 12, I'd add 12 over 12, because they have to add 1 pi. Anything divided by itself is 1. So 5 pi plus 6 pi is 11 pi over 6. Okay, here's the hard part. These two answers that we find when we solve this, like we do with regular trig equations, aren't the whole entire answer. There are other angles that also make your equation true. So notice that all 4 of these angles are between 0 and 2 pi. Right? And we want to know all of the angles between 0 and 2 pi. The ones that we calculate aren't enough for this problem. Okay, here's our second example of our multiple angles. So we solve it basically how we always. So plus 1, because we want to get the thing away from our trig. So the tangent of some angle divided by 3 equals 1. Okay, I'm going to start with an angle, divide that angle by 3, and then take its tangent, and that answer should be 1. Okay? Oh, I have to move tan. How do I move my tan? Inverse tan. So I'm going to move my tan to this side by doing the inverse tan, because we want to get theta alone by itself. So my next step is to find my 2 angles, right? Because there's almost always 2 angles where my tangent has this value of 1. So what is one angle where tangent is 1? Pi over 4. And what is the other angle where tangent is 1? 5 pi over 4. So tangent is positive in the first quadrant, and tan is positive in the third quadrant. So pi over 4 is your first quadrant angle where tangent is 1, and 5 pi over 4 is your third quadrant angle where the tangent has a value of 1. Okay, now solving this for theta, your variable, we multiply both sides by 3, right? Because that's how we get rid of division. It's theta divided by 3, so the opposite of division is multiplication. So one of my angles is 3 pi over 4, and my other angle is 15 pi over 4, which means we have to do some analysis. Is 3 pi over 4 between 0 and 2 pi? Yes. Yes, it is. Is 15 pi over 4 between 0 and 2 pi?
No.
How do we know? Well, what's 15 divided by 4? That's 4.75 because 16 divided by 4 is exactly 4. 15 divided by 4 is 4.75. 4.75 is bigger than 2. So we have to throw away this answer because it's not in our domain. Our answers have to come from between 0 and 2 pi. 15 pi over 4 is too big. So it doesn't work for this problem. Our next example. 2 sine of 3 theta equals 1. Okay, so order of operations. If I were to say evaluate, the first thing you do is you would multiply your angle by 3. And then you would go to your unit circle and take the sine of that angle, and then you would multiply it by 2. And when we do all of that, we have to get an answer of 1. Okay, so let's see what happens. We need to divide by 2. Divide by 2. Right, pretty straightforward. Sine of 3 times some angle equals 1/2. Okay. Move our sine over by taking the inverse. The inverse sine of 1/2. Okay. How many times on your unit circle is the sine 1/2? 2 times. 2 times. There's 2 times for almost every angle. What's the first place on your unit circle where the sine is 1/2? Pi over 6. And the second place is 5 pi over 6. Okay, when we're solving simple trig equations, right, we're done. Those are the answers. Well, now it's 3 times some angle equals pi over 6. So we want to divide both sides by 3. In other words, multiply by 1/3. Okay, dividing by 3 is the same as multiplying by 1/3. Okay, so our angle turns out to be pi times 1 is pi, 6 times 3 is 18. So pi over 18 is one angle, or 5 pi over 18 is another angle. Okay, we know we're going to have more, so let's see where these angles are. Where is pi over 18? Well, pi over 18 is 10 degrees. Because what's 180 divided by 18? 10. So pi over 18 is here. Where is 5 pi over 18? If 1 pi over 18 is 10, then what's 5 pi over 18? 50. So both of these come in the first quadrant, which means we're potentially going to have 2 more angles over here, 2 more angles from down here, 2 more angles. We're going to potentially have 8 answers. But let's see if that's actually true. So what would this one be right there? How many pi's over 18 is this angle right here? Well, this is 1, and that's 5. How many is 90 degrees? Do you know? 90 degrees is 9 pi over 18, right? Because it has to reduce to 1/2. 90 degrees is pi over 2, so our fraction must reduce to 1/2. So if I have a denominator of 18, my numerator has to be half of it. So 9 pi over 18. And what's 1 more than 9 pi over 18? 10 pi over 18. Can we reduce that? Sure we can. They're both divisible by 2. That would be 5 pi over 9. Okay, so let's pause for a second and see if that's actually true. So our analysis says that 5 pi over 9 is not a real angle. Okay, so we're going to scrap that 90-degree stuff and just go straight to your adding pi. So what are my other angles? What is 1 pi over 18 plus how many pi's? 18 pi over 18. Because pi 18 divided by 18 is 1. So what's 1 pi over 18 plus 18 pi over 18? 19 pi over 18. Or, what happens if I add 5 pi to that? I get 5 plus 18 is 23 pi over 18. Okay, our last example has a radical in it, which I know you can handle. So we do these simple things first. Minus 2. Divide by root 3. Okay, so hopefully we have memorized if we have 1 over root 3 as a fraction, that rationalizes to become root 3 over 3, right? Memorize those rationalization things. So we have the cotangent of 2 theta equals root 3 over 3. Okay, so we move the cotan over by taking its inverse. The cotan inverse cotan of root 3 over 3. Okay, so how many places is the cotan root 3 over 3? At least 2. There are 2 angles where the cotan is root 3 over 3. Okay, the cotan is root 3 over 3 when the tan is normal root 3. Where does that happen? Pi over 3 and 4 pi over 3. Right? Both of those come from your unit circle. So make sure you have a unit circle to refer to when we are solving trig equations. Unless you have memorized all of them, which I didn't ask you to memorize, I want you to use your unit circle. So divide both sides by 2 means we multiply by 1/2. So our first angle is at pi over 6. And our second angle is at 2 pi over 3. Because 4 pi over 6 reduces. 4 divided by 6 reduces to 2 pi over 3. Okay, so what part of our unit circle are both of these angles located? On the top. Pi over 6 is right here in the first quadrant. So since both of these answers are in the top half of your unit circle, we're going to have 2 other answers that are 180 degrees apart. So what is 180 degrees or pi units away from pi over 6? 7 pi over 6. And what's 180 or pi away from 2 pi over 3? 5 pi over 3. So we have 4 angles, pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. Okay, so if we want to make some generalities, if we are multiplying with our angles, 2 times theta, 3 times theta, 4 times theta, we're going to have multiple angles from your unit circle if we are multiplying. And if we're dividing our angle, we're going to have less answers from your unit circle. Okay? So you have some practice. A lot of them are multiplication. Remember to add pi to the answer that you calculate. Have a great time solving these equations. Okay, bye.